Sebastian and Bryce. We are doing our project on React.js. React, also known as React.js, is a JavaScript framework used to create sophisticated user interfaces or UIs for web apps. React was initially launched by Facebook, and then it was made open source a few years later. The reason it was created was Facebook needed a way to make more complex interfaces that loaded more quickly and used less resources and just all around was more efficient. It allows us to write both JavaScript and HTML in the same file, effectively consolidating our front-end code. As you develop your app, it will change in real time as you compile and test your content, allowing you to see changes in real time, which obviously speeds up development time and cuts down on development cost. React has many benefits to using standard vanilla HTML and JavaScript. Its main advantage is that React is able to be easily modularized. This allows pieces of your front-end code to be very easily reused in a similar way you would pass in new parameters to a function. It also allows many developers to be working on the same front-end code at the same time. React has a massive library of support with other libraries and has easy integration with the integration layer of an application and the backend. React also has a vast open source community, lots of documentation, and many people willing to support you in switching your front end to React.js. Some companies that use React, for instance, are Instagram, Netflix, the New York Times, Airbnb, and Discord. A core aspect of React is the use of the virtual DOM. The virtual DOM is a representation of the standard DOM. The DOM the DOM stands for Document Object Model. It's a hierarchy structure given to HTML documents and attributes within them. Some examples of this are the div tag, the section tag, the figure tag, and the table tag, which have corresponding attributes within those tags themselves. For instance, one example at the right you can see here is the table structure. Table follows a parent-child relationship with the table having attributes such as table data and table row, which then have their own sub-attributes of text and content themselves. And all of these can be used with React.js. Now, the specific differences between the virtual DOM and the regular DOM are that, number one, the virtual DOM is not the actual object you are editing. It is a representation using JavaScript to allow you to test and efficiently rework your code without needing to use the costly reloading of your entire site and all of your other resources. As such, it updates very quickly, and it allows for much more efficient development time, and it cuts down on development costs as well.
So now we'll talk a little bit about the specifics of coding in React. So as we mentioned earlier, React is modularized. Individual modules are called components or sometimes functions if you use a different design model. And you can think of React components as pieces of HTML code that have information and logic tied to them. The logic happens in the render piece of the code and is coded in basic JavaScript. In the example that we provided, this is where the console log statement is. Whenever a dependency relationship changes in the virtual DOM, as we previously mentioned, the render statement is rerun. This is important to differentiate from the return. A return statement will return JSX elements which are very similar to normal HTML, but can also include JavaScript injections handled in your render statement very easily. In the code snippet, the div element is in the return statement and acts as normal HTML. So as we previously mentioned, React is modularized. When you define a component, you can duplicate it very easily as we've shown below. The app class serves as a parent component for the button class and instantiates the button class twice. Instead of writing the button code twice, we can just call it like a function.
Now we've discussed modularization and the basics of coding in React, but we haven't touched on the flow of data yet. In vanilla JavaScript, communication between different areas of your front-end applications is pretty self-explanatory, but in React, the communication between components needs to be explicitly specified so that the virtual DOM can work. When a component of our application changes, We need these changes to reflect in other specific areas of our front end, but we don't want it to load the entire web page like in vanilla JavaScript. Components communicate with each other in React in two different ways, props and state. Props is used when static data is passed from a parent component to a child component that isn't meant to change. You can think of this as parameters passed into a function. State is used when information has the ability to change. We can have this information change within its own component, or even have the changes propagated through the virtual DOM to other components. For an example of props, we pass two different texts, the first hello1 and the second hello2, into the props of a child component that then renders these props in an h1 element. You can see this in the web page to the bottom right. For an example of state, we have a component which renders a name. The name is initialized to Andrew, but when you click on the header tag, it updates to Jack. The component does this through a callback function, which when called, re-renders the component and updates it in the front end to show the new value. In a slightly more complex example, we have two components which are connected. The component button is a child component of the app component and receives app state of click event in its props. When a button is clicked in the child component, the callback function in app is propagated and updates the state in its parent component. Whenever we click on the button, data in an entirely separate component is updated. This is extremely useful when propagating dynamic data throughout the entire application. React has some similar concepts to 3155. For example, it relies on higher order functions and callbacks, as we mentioned, and also has abstract data types of type class, child, etc.
Similarities now. For instance, callback functions, which are very pervasive in React and essential to how data flow works, are functions in which are declared to run at some point in the future, which means that they could be called at any time within this framework. React and JavaScript work on an asynchronous and synchronous clock that has many different components working together, and many tasks that have effects which need to be propagated after some other action occurred to maintain the flow of data. In the example below, we have a button component that is instantiated by the app component. The app component has a callback function called uncover that is bound to its modularized state, but instantiated instead by its child component, which is the button component. When someone clicks on a button, an event that can happen at any point in the future, the callback function is instantiated in the app component and a line of text is uncovered. When the button is clicked again, the same callback is then instantiated and the button disappears again. We keep track of the visibility of the button's CSS through the state used in the component and update it so it's automatically reflected in our front-end user interface. Here's a quick video demonstration about how the code works. Another thing that React relies upon is abstract data types, and as this is the same with callback functions, it is also essential to the operation of React. All components in React are essentially abstract data types, defined by a set of logic as we've shown, and able to be instantiated anywhere in the code base and reused at any point in the future. We'd like to thank you for watching, and we thank you for an excellent semester, and we hope you've enjoyed our presentation on React.js. Thank you.